Okay, now I think it's a good time for me to have a quick review about the Internet protocol and network. It's about like the computer networks, and it's just a version, a a weaker version. I mean that these parts are just 1 month ago we have learned, but it's a little bit not really. I don't have a clear mind about what I've learned, and now it's a good time for me uh, to have a quick review. And now I think it's I I just I forget about the 1.1 and 1.2 this thing. Okay, the first thing is that to directly to output what we have learned. The IP of math, the first chapter is about the introduction. So 1.1, what is the internet? The main idea is that I think it is just the network of network. What is the internet? They have different laws, different commit groups, and the 5 laws that is from bottom to top is that the physic physical law, link law, and network law, transfer law, and application law. There are 5 application, and what is the edge? And then there are different edge and the core. What is the edge? Edge is about the host and the uh, uh oh, I don't know what is the like the router and the switch. They are also they also belongs to the edge, I think. And systems, access networks, links, and so on. The network cores, and they are just to the 1.2 is just to recognize what is the edge. Edge means that it's not the core part. And what is core means that there are different structure, different things. Oh, I just neglected about the details. Okay, the 1.4, 1.5, and 1.6. The delays, and these are just something very, really easy. It's just a mathematical model to like what is the delay? Delay means that we just there is just a line that that is a ideal concept, I think, and some laws, some just a model to make a mathematical model and then to analyze it. It is a little bit easy. And then about the portal layer and the central layer. Okay, here we go. The network core. The network core means that mesh of interconnected routers. Mesh of interconnected routers. I mean that it is just a interconnected routers. And okay, I think the first thing is that to look at the picture and then do the analysis, these nodes, and then okay, these are just the cores, and then just about the edge. The colorful picture is about the core. Or what do you call core? Just about the transistor. I mean that the transportation bar. What is the edge? Edge means that okay, what is the application, and near the application, the end router. I think the last router is also about edge, and also another area is about the DNS. I don't know what is DNS. I forget about this concept, but these are just about the. Okay, I mean that the core means that it's a little boring. It is a little boring and just some One thing that is router and switch, I don't know, mesh or interconnect routers. Packet switching hosts breaks application log message into package. So the host breaks application log message into the package. Host. The first thing is that the packet not and the forward packet from one router to the next across the length and path from source to destination. Each packet transmits at full link capacity. Okay, these are just very easy for me, but why there are so many? The first thing we have learned that it's about the interconnected routers. Okay, there are some complement information that is packet switching. This means that hosts break the message into packets. And then what is the packet and what will they do? Okay, these are just something I don't get how they do. I just think that the package just from one destination to transport to another destination. I just neglect about the details and forward packets from one user to the next across links on path from source to destination. Forward packets from one router to the next. Forward packets from one router to the next across links on path. Forward packets. Oh, I should focus on the presence. Forward packets from one router to the next. Router to router, then packets from router across link, router. And pass from source to then each packet transmitted at full link. Each packet transmitted at full link capacity. Full link capacity. I don't know what is the full link packet switching. Okay, this is just what is the packet and switching. Packet switching process means that from one router to another router with the process of link transportation, and that's just something like the transportation that is what is the meaning of at full link capacity? I mean I know what is the meaning. It's just the max capacity. L bit per packet. The 1 2 3 and then RBPS. What is the meaning of BPS? Bit per second. From one router to another router. Oh, what is the router? Router is just on the third line, that is the network line. Takes some time to L bits and into store and forward. One hop transmission. Oh, one hop. This is the continuous mode. That is the L one hop numerical example. Enterprise must arrive at the router before it can be checked on the next link. End-to-end delay. Zero propagation delay. Oh, I think we should understand what is the propagation and transmission. Transmission means that it's just a data link. Okay, this one hop means up, down, up, down. And not about auto, it's about it's bridge. I think it's a bridge, but not up. So the first thing is that transmission means that transmission information to this. This just determine what is the destination you would choose. Okay, more on delay shortly. This is just the end-to-end transmission delay. End-to-end delay means that if we can only transmit in delay, what is the delay from setting one? Oh, this is byte, and times 8 is that 1.5. Oh, this is just some very easily to. Oh, this is just a please. This is one case 0.012 0.012 times 0. I think the final route is 0.018. That is okay. Mimo, or what is the MS? How to say it? How to pronounce it? Very easy. Okay, what we are learning is just a very easy model that is from one destination to another destination. We just use the bridge. This is just a router. The packet transmission. We neglect the propagation delay. Okay, packet switching. Oh, there is another delay. That means the packet switching, queuing, delay, and loss. There though, R equals to 1 Okay, what is the meaning of this? This means that okay, this bridge will allow different kind of guides to visit. So there are different queue or packets waiting for output link. Queue or packets waiting for output link. Queuing and loss if arrival rate in bits to link exceeds transmission rate of link for a period of time. If arrival rate in bits, queuing and loss if arrival rate in bits to link exceeds transmission rate of link for a period of time. Oh, I should be focused. Be focused. Waiting to be changed. Okay, this is just okay. Let's just make sense about the picture. What is the that is to say which is the two wait the wait, but there are different. Uh, it is just the different no regulations from red first or blue first, and the when we get this router, so how to when to output. Okay, these are just some problem, and I think there are some combination like four group is just four people is just one group, so we can together set. But I know that this is just randomly to choose, and queuing. There are queuing and delay. Delay is also about the transmission delay and loss. When it loss, when it will lose, it will just to send message to the send back message and then to repeat the orange mentioned. So wait, wait. Buffer packets can be lost if memory buffer. Why? What is buffer? Buffer. 2K network core functions. Routing. determines the source destination route taken by packet. Routing algorithm. Two key network core functions. Routing determines source and destination route taken by packet. Oh, be focused. Two key network core functions. What is the function that is to determine routing and forwarding? Okay, pay attention to the functions. So we have talked a lot about but what is the main function is that routing. Routing means that determine the source, which source, and forwarding more packets from routers input to appropriate router output. Routing means determines source destination. I think there are two. Okay. Oh, I just remembered what I've learned. It's about. Okay, let's just think routing and forwarding. Forward routing means the determine the source destination taken by packet. Routing. Okay, routing has the algorithms means that routing means determine and forwarding moves from router input to appropriate. Okay, let's check again. Routing means determines route. Determine route. And forwarding means the action. This is our brain. This is our body. And inner structure, internet structure, network of networks. Yes, it's just a network. Everything connect internet via access ISP, internet service providers, residential company, university, and so via access ISP, internet service provider. Access ISP inter must be internet so they can each other. Resulting networks of real is very complex because evolution was driven by evolutionary stepwise approach to describe current internet structure. To describe current structure, okay, let's try again what we have learned. We have learned about the core network and then about core and about the packet and the packet function and then packet and then do something that is the core network core functions. Network core functions. The key network core functions because now it's about the structure ISP and why it is about complex because of the social power. How to connect them different ISP? We showed some group, some middle scale, some large scale. Okay. Option we can one to one. Okay, we need a lot of information, but if we can connect to another global transition, customer provider have economic agreement. Okay, but it's a viable business, then it will be competitor. So they are different. But if one global internet exchange point, there will be competitor which must be internet that is the internet exchange point. ISP internet service provider. Okay, peering link. And the regional name must arise to connect access to ISP. Okay, so this is just a mathematical model. I think it's about a group theory. I don't think this, maybe not. Internet structure network and then content provider next may run their own network to bring own provider have their own network. Okay, this is just some internet structure networks. Okay, tier 1 switch, tier 2 and X switch and regional switch. Okay, there's something at center small charge of wheel connected large network. Tower component level 3 to AT&T, NTT national content provider like Google. Provide network that connects its data center to internet, often bypassing. Understanding the network edge, which of the following the network core or network edge tier 1 means the tier 1 is just a core edge. What we have learned, okay, we have learned about the internet, about the router's two functions, that is routing and forwarding, and about the packet transmission, and then the network of network. Okay, what we have learned, a network equal a network in between. Internet is between protocol scholars how system connect. This later lecture will explain those protocols. Edge are connected by powerful coaxial connected hence. Internet controls for Taiwan high brands tree exchange, CDN connect content distribution network pull CDN content distribution network push content close to users. Introduction to IP roadmap. Okay, the first thing we have talked about the network core, and then we will dive into the more mathematical, that is delay loss and throughout. So why will I just don't know? It is basically it's just randomly to come in and come out. So I should wait, but there may some average result to judge to value. Delay loss throws in networks. How do loss and delay occur? Packets occur in router buffers. Introduction to IP roadmap. What is the internet delay loss? Throughput in network. Delay loss, okay. Be focused. And how to loss and call. They are waiting, but there may some accident. Packets queue in router buffer. Packet arrival rate to link exceeds output. We should wait in buffer. Packet arrival rate to link. Okay, wait for turn being transmitted. Transmitted delay and queue delay and free available bus drop if no free buffers will be. Four sources of delay, that is propagation delay, transmission delay, queue delay, and what is the nodal process? For different process, nodal process and check errors. Okay, this is just a very small delay, very little delay determine the nodal processing queue delay time. Wait depends on the translation. It's about the transmission delay L times 2 divided by R. Propagation delay about the length times the speed. Okay, this is a very easy thing for us to understand. And transmission delay, not the processing and queuing and propagation. I just don't know about the queue delay, how to queue, and I think it's a very complex mathematical model, I think. Testing understanding source of delay, which of the four times packet weights behind other is a Q delay, QEUE delay, time a router takes to write the bit from take to the propagate write the bit from into the outgoing optical propagation delay it takes here to travel down. This the C is the propagation delay. The B time router takes to write the bits. Write means the this is right is the process nodal process I think that is another check iterary output. I don't know time it takes the router to determine which. This is just the nodal delay. I think the why is just the transmission delay. What is the meaning of? I think they are similar propagation and transmission. Okay, the why is just write the bit from a packet into the outgoing right down. Okay, the packet loss queuing in process aka lost packet one will be too much, the buffer has no room for the packet. Maybe retransmit by Pearson or the by source and system or by source in or not at all. Buffer. Throughput rate at which bits transferred between bit time unit instantaneous average. Instantaneous means the rate at a given point in time along server scanned bits and pipe that carry flow at rate Rs. Sender receiver. No, Rs is just some assignment. So our throughput means the rate at which bit transferred between sender rate. Okay, what is the average into and what is the average into and so photo Rs is less than, so it's about L plus L over Rs L over Rc. Link on the bottleneck link on end-to-end path that constrains. I don't know the meaning of link on. Throughput. Preconnected and my be often bottleneck. What is the bottleneck link? End-to-end constrains the path constrains the throughput. Throughput means I don't know what is the freaking thing. Why it constrains turn connections share backbone bottom bottom network link, throughput, throughput, intern, internet scenario per connection. So I just don't know what is the bottom link. What is the difference between path, Y path, conjure the throughput. What is throughput? Throughput means between rate between transfer and the bottleneck. What is a bottleneck? Bottleneck. I think it's the lower. I think it's just the lowest thing. Protocol law and service modes. Service mode. Protocol law service models. Protocol law they're just in the network law is the third network. Running links of varieties, protocol hardware spots, and transportation law. I don't know the protocol lies on the transportation law or the network law. Because is there any hope of organized structure? What result is network? So we need two different law to get okay. There are different organization that do it, give it on, take it, complaint, claim, package claim, check and claim, get load and okay, that's this very interesting. So functionality. Why we use the law? The first thing is that make it more easy, a clear logic, so that we can divide different functions into different code. We can debug and then to do engineering work in different groups so that the high efficiency to build this system. Second part is that we could have more protocol and more constraints into different levels so that we can enable more functions in this system. Why Lui? Okay, the first thing, so Learn consumption for displayed loss identification law reference model is maintenance, updating and change of influence. Lloyd reference model explicitly allows identification with a complex piece. TCP IP model application transportation. Oh, TCP UDP IP Internet Protocol means how to route. TCP UDP means the process, how to process transport network link layer physical bits on the wide data transfer between neighbor network elements, Ethernet, thread, Wi-Fi, PPP, transport product network routing of datagram from source to destination. Application supporting network application FTP, SMTP, HTTP, application FTP, SMTP, HTTP, TPTP, FTP. I don't UDP, link layer. What is the link? The data transfer between neighboring network elements. Ethernet, Wi-Fi, PPP transfer between neighboring network. I don't know what is a link. What is a link and the physical difference? ISO OSI reference model, Internet Standard Office, or Open System Internet International Standards Office presentation law a law application to internet place pizza 什么 pizza what fucking pizza law application to interpret meaning data in crypto computation extension means that checking find recover data exchange internet stack missing these layers. Why do you need presentation allows to interpret meaning of data like compression machine, specific conversion, and synchronization, and checking point recovery exchange. Okay, law inherits most laws of TCP and UDP. TCP/IP model okay. The first thing is the TCP/IP model are associated with a particular type of header, or sometimes a header and tweeter. Header and tweeter. What is tweeter? Header is the something information to determine what will they go and how to do, which belonging and to which how long, moment separate. There is a network which different hosts should receive data. Let's say transport port. A new header is added incorporating the headers underneath. Alloy 2 package has alloy 2 header, but includes headers at each new header. At each alloy header, at each alloy, a new header is added, incorporating the headers underneath. Alloy 2 packet has a okay. This is just added incorporating alloy 2 packet alloy 2 but include. Okay, this is just encapsulation message and then do something then link physics switch and later physical network and then do some more things like int I physical and then do some more thing one thing to another thing though that with destination. Okay, this is just the box to open and then to encapsulation. Name to advance our layer. The first thing is that we divide into different alloys so that we can make sense. We can divide the big system into the smaller system so that we can make more clearly to enable them to have different functionality. Or the second thing is that it's very easy to build and to recovery and debugs, and third thing that is clear logic and to do more protocols to set more protocols and to set more things. What is which header are included in a LOI 2? LOI 2 that doesn't have LOI 1 so that it has a LOI 3 the LOI 2 also has the link LOI and network LOI transportation and the message. Oh, header only have. Okay, I saw we have the application. The presentation means the just the translation. I forget what is the presentation. Presentation law interpret meaning of data. Interpret meaning of data, encryption and session Synchronous. TCP IP noise, application noise. I don't know, presentation session, so noise even application how you use this with the data for programs you use on the computer and file transfer set email transfer file transfer FTP law presentation law related to character sets and presentation of data. Character sets and presentation of data. Unused IP or real network internet. Law 6. Presentation law related to character sets and presentation of data. Unused in TCP or IP or real internet. Related to character sets and presentation of data. Character and data and session related whole lifetime connection for the end-to-end connection between machines and okay, I think this will make sense. Application data program for programs you use on your computer and the presentation related unused. BPO just like that. Application have low access to network resources. The device for noise. Router in the network layer and switch and repeat switch is noise readjust and works out. Router is about switch is just to try to about the layer 2 switch reach the it reaches the layer 2 and works out which nearby should simpler than repeater. Repeater is just repeater switch router. ISO is writer like white tomorrows or live. ISO SI on the plan by county. TCP transmission control protocol. Internet built by engineer. Design. Would it better if we had one design? Call it too big to change. Sessions line, plant line, useful but not existing perhaps, but we can get there from where we are. Which layer following give the name, the article, the physical layer, web browser, application layer, router, is the network layer router, which makes sure the packets are in the right order. I think this transportation law which gets work to the right machine anywhere on the whole internet law. So I just don't know the data link there. Notes. Please do not throw sausage piece away. Don't. No, please do not. What have we learned? Internet performance protocol law. Protocol law creation. Okay. History. Okay, the very easy history that one very old. I think very interesting to learn history is just to compare what they have because the 1946 the first computer has been developed, that is ENIAC, and I think during this time the first PC and Steve Jobs 1972, I think that's some easy thing for us. Okay, very it's a little complex for me to understand everything. I don't have time for me to have lunch. Goodbye.